This is exercise 6.3a, question 7. The line L with equation r equals -2, -1, 6 plus t times -3, 1, 1, and the points W with coordinates 9, -3, 1, and F all lie on the plane pi 1. The point J with coordinates 23, 34, and 23 does not lie in the plane pi 1, and the point F is the closest point in the plane to the point J. And we have to find the coordinates of F. So here's our plane pi 1. And then inside pi 1 we have the point W with coordinates 9, -3, and 1. And then we also have this line L. And somewhere on the line is the points -2, -1, and 6. Let's call it A. And then this line also has a direction vector -3, 1, 1. Clearly another direction vector that we can get of this plane is the vector AW. Let's go ahead and calculate that. AW is equal to OW minus OA. So that will be 9 minus -2 is 11. And then -3 minus -1 is -2. And then 1 minus 6 is -5. Okay, now it's time to calculate a normal vector to the plane. And one normal vector that we can get is -3, 1, 1 crossed with AW. Alright, so 1 times -5 is -5, minus -2 makes -3, and then we have 11 minus 15 is -4, and lastly 6 minus 11 is -5. And of course we don't have to take this normal vector. We can also take the normal vector n1, which is -1 times n, which is just 3, 4, 5. Just because I prefer to do it that way. Doesn't make a difference which one you actually take. And so we can write the equation of our plane pi is 3x plus 4y plus 5z is equal to d for some constant number d. Oops, plane's called pi 1, not pi. Alright, so we can go ahead and find d by observing that, for example, 9, -3, 1 is a point on the plane. So if we put in x equals 9, y equals -3, z equals 1, it should satisfy the equation. So we have 3 times 9 plus 4 times -3 plus 5 times 1 is equal to d. And, well, that is equal to 20. So the equation of pi is, or pi 1 rather, is 3x plus 4y plus 5z equals 20. Next up, if we go back to our picture, we're told the point J with coordinates 23, 34, 23 does not lie in the plane pi 1. So J can be over here. And we're told that the point F, which is inside the plane pi 1, is the closest point in the plane to the point J. Which means that the line from J to the point F must be parallel to any normal vector. In other words, if n is a normal vector, then JF is equal to k times n for some real number k. Let's put our origin over here just for the sake of it. Okay, and then we observe that the vector OF is equal to OJ plus, well, jf. And then as we discussed, jf is some multiple of the vector n1, since n1 is a normal vector. So oj plus k times n1. Okay, now oj was 23, 34, 23. Plus k times n1, so that's 3, 4, 5. Okay, so to simplify that completely, it's 23 plus 3k, 34 plus 4k, and 23 plus 5k. So in other words, the point F has coordinates 23 plus 3k, 34 plus 4k, and 23 plus 5k. And since F is in the plane pi 1, if I substitute in these coordinates for x, y, and z, they should satisfy the equation of plane 1. So 3 times 23 plus 3k plus 4 times 34 plus 4k plus 5 times 23 plus 5k, that's equal to 20. Now let's expand this thing out. We have that 3 times 23 plus 4 times 34 plus 5 times 23 is equal to 320. Then we have 9k plus 16k makes 25k, plus 25k makes 50k. And so that's equal to 20. So we have that 50k is equal to negative 300, so that means that k is equal to negative 6. And so now it's very easy to find the coordinates of the point F. It's the same as the coordinates of the column vector OF. And so we just put k equals negative 6 into here. So we have 23 minus 18 is 5. 34 minus 24 is 10. And 23 minus 30 is negative 7. Moving on to part B, we're asked to find the distance of the plane, so the distance of pi 1 from the point J in the form a times square root of 2. Well, the distance of the point J from the plane is the distance, which is the length of JF. And JF is this vector here. It's k times 3, 4, 5. So part B, we have that JF is equal to k times 3, 4, 5, where k is equal to negative 6. So that would be negative 18, negative 24, and negative 5 times 6, so negative 30. And I just realized there was no point in writing that out. It's actually better just to leave it as negative 6 times the vector 3, 4, 5, because we're just calculating its length anyway. So the length of JF is equal to the absolute value of negative 6 times the length of the vector 3, 4, 5. So that would be equal to positive 6 times the square root of 3 squared plus 4 squared plus 5 squared. And 3 squared plus 4 squared is 25. So that would be 6 times the square root of 50. And I believe it was supposed to be in the form a times square root of 2. And 50 is 25 times 2. So this is 6 times 5 times square root of 2. So that would be 30 square root of 2. And that's all for this question.